Problem 1 has 3 parts, and the first part is to find the degree of the polynomial. If you need more information on how to do this, watch the lesson video. I'm going to show you how to do the homework problem, but not explain all the details. So the degree of this polynomial comes from multiplying the 2x squareds together. This would be a 4th degree polynomial. To find the x-intercepts, we need y, or f of x, to be a 0. So we need x squared minus 81 times x squared minus 36 to be 0. To solve this by hand, we break it down into x squared minus 81 equals 0 and x squared minus 36 equals 0. If x squared minus 81 is equal to 0, x squared is 81, so x would be plus or minus the square root of 81, which would be 9 or negative 9. X squared minus 36 equals 0 means x squared equals 36, or x would be square root of 36 plus or minus, which means negative 6 and positive 6. So there are our 4 x-intercepts. To find the y-intercepts, we need to substitute 0 for x. So 0 squared minus 81 and 0 squared minus 36 would give us a negative 81 times a negative 36, which we can do on our calculator. Question number 2, the A part, asks about the degree of the polynomial that would give us the graph over on the right side. And again, watch the lesson video if you don't know what they're talking about. But for this one, we see the graph coming up and curving 1, 2, 3 times. And so a graph that curves 3 times would be a 4th degree polynomial. And even degree polynomials, where the graph is going down on both sides, has a leading coefficient that is negative. For this function, called a rational function, the x-intercepts for a rational function can be determined from the numerator. So if we take the numerator and set it equal to 0, whatever values of x we get would be our x-intercepts. We can find the y-intercepts by, like we did before, plugging a 0 in place of the x. The domain of a rational function is going to be all numbers except for the ones that make the denominator 0. So we're going to take the x plus 1, set it equal to 0, and solve for x. So the answer for the domain is all numbers except for -1. The term vertical asymptote means the vertical lines where we have no graph. Now we've already done that, so I'll just point you to it up here. Here is the vertical line where we have no graph. So the vertical asymptote is the x equals -1. The horizontal asymptote is a different story. Again, you need to watch the video for more, the lesson video for more details. In looking at the rational function, if the degree of the top is the same as the degree of the bottom, both of these are first degree, then you divide the coefficients of the x's. And so y equals 6 would be the horizontal asymptote. Now in choosing the graph, we could either use the information that we just got through answering, or we can enter this into our calculator. Now I'm going to use the TI-84 calculator and show you how to enter that into the calculator. On my calculator, I used, and by the way, on the TI-84 calculator that I'm using, every button I push is going to show up in red as I push it. In the area to the lower right where it says key press history, it lists every button that I push. If I go too fast, then you can always rewind the video. So if I go to the y equals key to type in a graph, I want a fraction, so I'm going to go to the math FRAC menu and pick number 1 n/d. In the fraction template, I'm going to type 6x, scroll down and type x plus 1. Since this is my first time using the calculator today, I'm going to begin with zoom number 6, standard graphing window. Now let me mention that on the problems that you see in the My Math Lab homework, they tell me out below what range of values to use for x and y. I can set my calculator to exactly match that using the window key. My x min is -10, just like in the problem. My x max is 10, just like in the problem. My y min I can change to -30, like it says in the problem. And my y max I can change to 30, like it says in the problem. And so now my graph should look exactly like one of those. So I'm looking for a picture that exactly matches this. In this problem, the instructions are use the cubic regression on a graphing calculator. Now, I sent out an email earlier showing you how to get a free TI-84 graphing calculator on your computer. You can also use the Google Play Store to get the same free graphing calculator on your Android phone. Or you can go buy a TI-84 calculator. But here's how you use the cubic regression. In looking at the instructions in this problem, notice it says x equals 0 corresponds to 1980. So over here on my chart where it says 1980, I'm going to be using a 0, which means 1985 is a 5. 1990 would be a 10, 15, 20, 25, and 30. So now I'm going to take out my calculator. We start with the Stat button. It's the one in red. Then Edit. We're going to go up. On my calculator, you see L2 is highlighted. I'm going to push Clear and Enter. Now that wipes out the second list. I'm going to do the same thing for list 1. And now I'm prepared to type my numbers. On the left side, I've got 0, 5, 10, 15, 20, 25, and 30. I'm going to cursor over to list 2, L2, and I'm going to type the numbers on the right. Before I exit, I'm going to make sure I have the numbers matching up like they are in the table. I go second quit. To do the cubic regression, I push the Stat key. Let me clear out all the keys over here so you can see. I push the Stat key, go right to where it says Calc, and choose Cubic Regression, number 6. Now I've already entered my values, so L1 and L2 are where I entered my values. I can scroll down to calculate and press Enter. Now that's all there is to it. So now my answer, as you can see on here, comes out to be negative 0.007 x cubed plus b 0.344 x squared plus c and plus d. Now let me mention that I have already set my calculator to round off for me. The instructions in the problem say to round to 3 decimal places. If you have a TI calculator, you can go to the Mode button right here. You can go down to the line that starts with the word float, go over to the number 3, and press Enter. That means all the numbers will be rounded to 3 decimal. So that's the answer to the A part. Now I'm going to take my time to type that in, and then we'll come back and work some more problems. The B part asks me to pick out the correct graph. Now you could take your TI calculator and enter the answer we got to the A part for Y1 and push the graph button, and you should see a blue line that looks like one of these. However, I can also just look at the equation. A negative number on the front of the x cubed tells me it starts off going down, then it's going to go back up and back down again. So I need a picture that goes down, back up, and down again. Now unfortunately that only narrows it down to 3 choices. So it is not this. Down, up, down. So it's one of these other 3. Also, if you have watched the lesson videos, you'll know that the whole idea of regression is that the dots and the line should come pretty close together. I'm looking at this picture and I don't see dots anywhere near the line, so it's not that one. It's not the one on the right. It has to be this one. The final question is asking us to use our answer from the first part to determine the fish consumption in 2018. Now, the only thing I need to spend brain power on for this one, and then I'll turn it over to the calculator, is to figure out what 2018 means in light of my equation. Now remember, in the beginning, x equals 0 meant 1980. So 2018 would be 38 years after 1980. So 2018 must be x equals 38. So I need to take the equation from part A and substitute a 38 in place of the x. You can do that manually. I want to show you how to do that on the calculator. On my calculator, when I did the stat calc number 6, L1 and L2 were correct, and I just went down to calculate. Now here's another option. If I'm going to be needing that equation for other calculations, out beside where it says store, R-E-G-E-Q, I can tell it to store that answer. And so I'm going to push the VARS, YVARS, function number 1. And so now when I calculate the cubic regression, just like I did before, I can go to my y equals and see that it is stored in y1. The neat thing about that is to evaluate that function with an x equals 38, I can go VARS, YVARS, function, y1, parentheses, 38. And so there's our answer. Now again, the other option is for you to literally type that with a 38 in place of the x. And I'm not going to take the time to do that. I think you can handle that on your own. However, notice it says in the instructions to round to the nearest whole number, which means for this problem that would be 22. Question number 5, we're going to take out our calculator, go to the y equals, clear out what's there, and type this. To type the fraction, 6.5x over 101 minus x, I'm going to use the fraction template. Math, FRAC, number 1, 6.5 x 101 minus x. Now again, I can look at these pictures and tell the range of values on x's are 0 to 110. And the range of values on y is the same. So I can go to the window setting, change x min to 0, x max to 110, change y min to 0, and y max to 110. And the picture I see should match up with one of those. second part. It says use the model to determine each of these. Now, basically that means plug those values into that equation. Now, I just got through showing you how to do that, and I will do it that same way. If I go to the home screen, I'll just use VARS, YVARS, function, Y1, parentheses, and 0. Now, you and I could do that one in our head, by the way. So that comes out to be a 0. So I'm going to enter a 0 in the first box. Now look, I can do second, enter, and it duplicates what I just typed. I can scroll to where I typed a 0 and type a 20 and press enter. Now, there is a little issue with how I answer the problem. Do not type 1.605. If you read the problem, you notice that the y values are in thousands. So 1.605 is really 1,605. And you continue on with the other ones. So here's what I typed in my calculator, and here over on the left is what I entered in the answer boxes. Now, the final part of the problem asks us to determine the feasibility. Feasibility means, is it possible? So you got two choices. Either it is possible or it's not possible. All you have to do on your calculator, again, is use 100%. Can you remove 100%? So if I do this same calculation with a 100, and I get an answer, then the answer is yes, you can. And so it is feasible to have 100%. I'll give you a little heads up. If it says error, then you can't.